In this session, we'll be discussing about the procedure how to apply the TH analysis, time history analysis to your structure. So, as you know very clearly, it provides the response of a structure over time during and after the application of the load, and you try to analyze the structure's motion equation. You are trying to solve the structure's motion equation. This is the fundamental, the challenge which you discovered during this course of analysis. And the time history response of a structure is simply the response or the motion or the force which you apply to your structure and is being evaluated, which is a function of time, including your inertia effect and other loading contributors. So when you talk about the steps, you can have the time history function definition and the time steps and the analysis parameters. So we'll look how to do this, and also you can see here the time step. So time steps, this concept I will talk, arrival time also I will discuss, and the damping factor also I will discuss. So we'll take one example, and through that example we'll try to understand all this concept. So from our exercise folder, the folder TH introduction project TH, you can open directly, and once you open this particular project, you can see the dimensions already. These dimensions are given here. So let me start with the analysis, and I will brief what all different steps you need to execute. So as usual, you can go to the load definition, and here you can see the definition part, and here already I have defined. So this I will be deleting so that you can understand the correct steps. So once you go to the time history definition and you go to add, here you can see the time history. Here you can see define time versus acceleration, or you can have a harmonic function, or you can have a external file. You can have different options. In our other two projects, I will talk about this harmonic and these two options. In our first project, let me start with the external file. So this external file carries the information of time and acceleration. So how it looks like, that I will show you, and I will give a look and feel. So if you go to your introduction project, and here you can see this particular input file ta_in, and if you open this, you can see you have this information. So this is your time, and this is your acceleration, and this is your time, and this is your acceleration, this is your time, and this is your acceleration. But one thing you can note, 0, then 0.2, then 0.4, 0.6. So 0.02 is the time step which you keep on adding, and you can see 0.46, and if you add 0.02, this will be 0.48, and this is the acceleration, and you can have negative acceleration also. So these are the information, as I told, the nearly 1000 information, and here you can see 22.5 is the time at the end of the time step, 22.5 second. So we have split it 1 second, you can see, into this many part, 5 different part. So 1 second is segmented into 5 part, and this total you have 22.5 second. So these many segments you will get. So this particular file you have to load. So this you have to save in your project folder where you are doing. So this ta_in, just I will copy this file name which carries this information. So here I will type this name .txt text file, and here you can see the loading type is acceleration, and this same input, if you go for force, the same second column instead of acceleration will be force, and if I'll go for moment, the same second column which I have loaded will be your moment. So I am interested to have acceleration for my case, and you can go for save, and I'll go for add, and this particular type will be the serial number which you have to give, add, and once you add this, here you can see the read ta underscore in.txt is executed, and this information you will get in your start editor also. So you can go to find, and this you can see read t underscore in.txt. So whatever the new name or changes you will make, you can just edit here and it will execute that. I'll go to exit, and next I'll go to the define parameters. So this define parameters, as discussed here, will be the time increments that you are going to use delta t, use for the analysis. Output time step size should be small enough so that you can just get the more close result, accurate result with respect to your analysis. So here you can see whatever the time step you have, that you can specify here. So whatever the time step specifically you want to define, so that already we have loaded, or you can go for 0.02, which presently we have, and you can have a damping factor to allow the system to absorb the vibration, or you can specifically have C damp or M damp. I will discuss this. I'll just go to add and I'll go to close. You can find this particular information. So the accuracy fully depend on the time step which you have specified, and arrival time also you can specify here. So once you see here the arrival time, this arrival time is nothing but when exactly you would like to start your analysis. So this can be 0 and this can be positive value also. So let me show you this. I'll go to the edit and you can input your values. I'm starting with 0 time, and you can have the positive values here. And once you specify this, you can have automatically, you will see the change option. Just to go to change and close it. So this you can see the damping is specified and arrival time is here specified, the 0, 1, 2, 3, 4. So you can start your analysis either at the 2 or 0 or 3 or any space or multiple of that. So that I will show you how to do that. So arrival time is the time at which a load assignment begins and can be positive or negative or 0. So begins at time 0 by default, and if you specify negative time interval, that means it will neglect the first 3 seconds of the input function. So negative 3 is nothing but it will neglect your first 3 seconds and you can start your analysis. So mostly we'll use the positive, and that you can see here. And the damping which I discussed here, the C damp or M damp which you have, this also specifically you can use if you have the composite damping case, or you can have the basic damping case that you can specify here. So damping is used to specify a single modal damping ratio which will be applied to all the modes, and the default value is 0.05, and you can use C damp if this ratio has been specified under constant based on the type of material. So you can use in the material constant, and M damp is utilized for calculating the individual damping ratio for individual modes, that is achieved through the means of M damp option, and this also you can apply through your code editor. So let us look at this skill factor which also you can specify to converge your unit, maybe English or maybe your British unit, so that you can specify. And if you have a metric unit, you don't need to do anything. If you want to convert to British, you can use 32.2 scale factor. So what to use this and how to configure this, that I will show you. So after specifying this, you can see this all information. You can go to the start editor and here you can specify your scale factor. Just you come below. Here you can see the acceleration, arrival time, and here you can give your scale. Whatever the scale factor you have, that you can give. Let us say I need to convert to a particular unit, that scale factor you can specify here. And this is basically your damping. This also you can change here. Arrival time, already I told, so that you can also specify. And now let us look at the different cases which you do configure. So first of all, after assigning all this, you have to go for the dead weight in all the y direction. So you can specify, so I have splitted and applied it. So you can apply the dead weight to your structure, and then you can apply the live load, or you can say the floor load, that is 5.5, which you can apply, and then you can go for the dynamic cases that I will show you. So whatever the time history definition you do configure, that plays the critical role, and you can see the whatever the definition you apply and whatever the cases you apply, like the time integration or the time step, that you specify in your particular file. And here you can see whatever the external file you have, so that I will specify .txt. So this is very important. So this already I modified that while showing you this other option. So this particular file or whatever the definition you have here, read, that automatically reads whatever the text information you have stored. Next we'll look at the different other cases in our coming session, and we'll look at the load combination and other cases.